Hi everyone, welcome back. So we are going to have a bit of a discussion about delivering steel reuse in practice, but we'll start off with some introductions. I'm Anna, I'm an Associate Director at Bureau Happold, and I'm also involved with the Circular D-Tank and the Engineers Reuse Collective. So if we just go along that line.
I'm Harry Price, I'm Major Projects Director for Severfield. So I look after sort of all things pre-construction on our large sort of capital projects, but also have quite a lot in our business to do with sort of all things reuse.
Hi, I'm Titus Akpan. I work as a project manager and reuse lead for Emerald Steel. So I look after and manage the processes for reuse for Emerald Steel.
Hi everyone, my name's Laura Batty. I work at Hain-Tillett Steel where I run the research and innovation team. I'm a structural engineer, but I work on basically trying to get innovations and new things trialed in practice and then talking about them.
Hi everyone, Tom Harf here. I'm structural reuse lead at Maconda. We're a circular economy consultancy, but my background is in structural engineering, and I've worked through all sides of the steel reuse supply chain, from being on demolition site and an EMR as a stockholder, and now looking at wider circularity practices for steel.
Okay, Roy Fishwick, Managing Director of Cleveland Steel. We have about 7,000 tonnes of reclaimed sections, 100,000 tonnes of pipe currently, also reclaimed and repurposed. So we've been doing this, I've been doing that for just short of 40 years.
Great, thank you. Okay, so I think just to get us started, we have a couple of slides that you're going to run through, Harry?
Yeah, I'll do it. I'll stay seated, I think.
Yeah.
So, are we working? Yeah.
Yeah.
So, what we've wanted to do, I think I did a project burst last year of just literally 2 slides that sort of talked a little bit about some of the work that Severfield are doing. So we'll just sort of put a little bit more meat on the bones for this year and just talk you through a little bit of our process for, you heard from Jonathan earlier on the sort of the documentation, the industry sort of literature that's out there for how we use sort of reuse steel. I just thought I'd put a little bit of an explanation on what that then means to us as a fabricator. So how do we work to these standards, and what do we then have to do as a business to run to the standards? So what we have there is a little bit of a picture of our own stock of reuse steel. So whilst we do look at buying material from the likes of Roy and as well as EMR and others in the market to use reuse material on our projects, what we also started doing as a business was designing our own temporary works to be able to be reused in future projects. So we do quite a lot of large, heavy engineering projects, large stadia projects. If you just sort of flick on. So this was Everton Football Club. So we designed the temporary works. So we have our own sort of reusable, demountable temporary work solutions for standard buildings. So they just get used time and time again. When a project necessitates something a little bit more complex, we will design our own temporary work schemes in sizes such that we can readily then reuse them in either distribution projects or commercial projects. So the benefit of that to us is it means that whilst, obviously we've talked this morning about how we test material and how we verify it for use, we have the original mill certs. It's material that we've bought. It's already in our sort of our ERP. We have access to all of the test certs, so we can sort of create our own little circular economy. That's been a bit of a phrase for today, hasn't it? Sort of create our own little circular economy to reuse steel. So this is some of the sort of large temporary works being dismantled and removed from site. What we'll then do if we move on is we have a live stock list, which we can also import others. We can take, say, Roy's stock list and add that in, and we've built model plugins so we can look at any project as it comes to market, from whether it's tender stage, early engagement, or whatever, and instantly flag up within that building as it's currently designed what we can take from either our stock or someone else's stock, where we can use things. It's got a bit of a color coding system, so if things aren't quite not a perfect fit, and we want to go and talk to the engineer about perhaps a small section size change, would enable us then to use something from an existing stock rather than buying raw material. So I won't go into the next detail sort of right now, because you won't see it, and that's the point. There's a sort of a detailed 15-stage process of how we deal with this material as compared to buying virgin steel. You know, pretty straightforward process. We model it, we order from a mill, we get it to the exact specification, we fabricate it, quite straightforward. I've on the next slide summarised exactly what we have to do to go through that reuse practice. So this is aimed at our own material, not necessarily from a stockist, but it would be a very similar process. So for us, it's how we receive it, verify it versus its delivery note. You know, it's all well and good of saying we've got all of the test certs and all of that sort of the original documentation. We've got to make sure what comes back from site is that actual piece, so we marry it up, so there's a process there. Assessing it, inspecting it, grading it, evaluate any damage, go through the same process under sort of P427 of ranking it, sort of from prime to E. And we have, if you can make it out, a little internal metric. We don't, you know, we talked a lot about sort of commerciality today. We have just a guidance metric of everything's in hours per ton for us. If we can't make it good within a 4 hours, sort of 4 hour per ton envelope, at that point then it's uneconomically viable for us to reuse it, and it would go down the existing scrap route. Then, you know, if I won't sort of labour picking up on the sort of the stuff that Jonathan did earlier, then it's going through the sort of preparation fabrication process in line with the documentation, again sort of same verification sign off, and then going into the fabrication process. So just wanted to show really, just to get a bit of an idea on where we're at in terms of cost parity of the additional steps that need to happen for us to then process something through the fabrication facility. So that's kind of it really. Whistle stop tour.
Yes. And you've mentioned test certificates and mill certificates a couple of times there. And we're all quite aware that that's not something that people actually see or have to deal with very often. So we do have one of those there. I think, Roy, can you just explain to everyone what they're looking at, please?
Yeah, sure. So essentially, material properties of steel are declared in a mill test report or mill test certificate. Realistically, it's only looking at the properties of the metal. The dimensions are actually basically covered by ISO 9000. So a mill test cert gives you the things that engineers need to know normally. So you've got the tensile and the yield, which is basically the strength of the steel, the elongation, elasticity, and the carbon values, which are derived from the chemical composition. Now you get all of that data on the cert, which is on the left. That's a standard mill. It's from Liberty, that one, but they all broadly look the same, laid out a bit different, but have the same data on them. By doing independent lab reports, you can actually get the self-same data set. So it's perfectly feasible to establish the grade, including the subgrade. Just to mention, because people don't always know, but the subgrade really comes down to what temperature you do the testing at. So it's just, for us, it's just as simple as making sure we ask the test house to test it at -20 or 0 rather than at 20 or 0 and get the wrong answer. For reassurance sake, it's often the case that something that passes at JR at +20 will pass at -20. It's surprising how often it will actually translate down through for the normal grades. So yeah, basically, it's perfectly feasible to establish the properties of the metal. And then the other thing I always say after this is with reused steel, you know it's been used once already. So unless anybody's sitting here with a high degree of confidence there's been a load of rubbish pushed out into the market at some point historically, what you're really doing is validating. Yeah.
So the mill report is what you'd get for new steel, and the lab report is what you'd get with your reused steel. So for all intents and purposes, where we're an engineer coming to design with that steel, we're getting the exact same thing on paper that we would be getting if we were
using and the fabricators are getting what they need because they need the carbon equivalence values as well for fabrication. So weld procedures and things like that.
Great. Okay, I might leave that there for a minute. But maybe one for you then, Laura. For engineers coming to this process, what are the things that engineers need to think about, and how much knowledge do you think engineers need to have when they're starting this process and looking to actively reuse steel on a project?
Yeah, so I think if you'd asked me that 4 years ago, my answer would be different because we're constantly learning, learning from mistakes, learning from what went well, from what didn't quite go well. But fundamentally, we need to know the material properties, which, as Roy said, are easily learnable from a lab report as opposed to a mill report. You need to know the grade that you're dealing with. You need to know what design checks are slightly different. There are very few, and they're very slightly different. It actually doesn't make a whole lot of difference whether you're designing with new or reused steel. And then once you've validated the reuse piece in your new design, good to go. There isn't actually a whole lot to do. Obviously, I'm simplifying a little bit. Sometimes it might be a little bit more complicated because you have to rerun a bunch of analysis. So, it's not free in terms of time. Other times you're aware of what can just be simply swapped for a lower grade, but most of the time it's actually not a huge deal, and we don't seem, we're not offering it as a separate business because it's easily, you can easily roll it into the work of a normal engineering design.
And then I think probably for Roy and Titus and Harry, the comment that we then sometimes get back from contractors or fabricators is what do they need to do and how much more effort is it going to be and who takes responsibility for which parts of that process. So what advice would you give to engineers for how to answer those questions and where should the responsibilities sit between the different parties?
For me, what we've learned, again, down to Laura saying we've got to learn over time, ultimately we engage with the fabricator. So fundamentally, the start of the relationship is always with engineers, but engineers don't buy metal. So we end up having to actually engage with the fabricator at the end of the process. So what we have to do is address their concerns. And what that's crystallised to, in most cases now, is us providing them with something that looks as near to new as possible. So we're doing most of the work before it gets to the fabricator, not expecting them to do it. That gives everybody greater cost certainty. The one decision we're taking is whether to do the work or not. So if something's a horrendous amount of work, we don't offer it on a job where somebody's going to have a high sort of selection criteria. We just don't offer that piece. And that's a very important aspect, whether you're a stockholder like us or whether you're trying to work material back into your own job. It's not just a question, I've got a piece of metal, we're going to use that. You should ask, should we use that?
Yeah, I mean, I think for us it's when we talk about it in practice, obviously there's a well-established sort of methodology in P427 for how we sort of verify, how we grade bits of reused steel. It's then taking it to the next step in what the information looks like from, I went on a bit of a rant in our roundtable this morning about people only talk about tons, and it's sort of, you can talk about 2,000 tons of reuse, it's irrelevant if they're all a metre long and you can't use them anywhere. But for us, from this perspective of how we put it through the shop, it's when we're starting on the journey and we're trying to understand whether we can use any reuse, how are we having the information communicated to us in terms of attachments, where they are, where holes might be, how it's physically going to go through any of our machines, what the surface treatment is, what, like to Roy's point about them sort of doing the work. If it's got intumescent paint on it and someone's going to need to blast that off, who's doing it? Is it, it's how that is communicated to us. It's fine if we've got, if we're lucky enough to have a length of steel at the right size that can be used on a job. It's then that next level of detail as to, aside from just a photo of here it is, there's no standard sort of spreadsheet format for how that information is communicated to us. So we know commercially and practically what we're then going to have to do with that beyond a manual inspection and, physically looking at the thing.
But who would you expect to be defining what needs to happen to it?
It's a difficult one.
I think, so I'll come from a demolition or deconstruction perspective. I would say the responsibility at that point sits with the demolition contractor. So for us, coming from the Coleman's group, we've had, for most of us that know us, we've had over 65 years experience with demolition and deconstruction. So looking at the SCI document, we've gone through that and we've understood what the processes are like. And then we've married that together with our experience in deconstruction. So just like Harry said, the whole process of documenting, physical verification and checks. We have an in-house model where we've structured and we have strategies of doing that. So when we send out materials to maybe Cleveland, they'll have the information. Is there paint on it? We try as much as possible to give every detail as possible. If there are holes, to be honest, we would not send out any material that is bent. The techniques of dismantling is really important. So the yield and quality of materials you get for reuse begins from the site. If you do not have an experienced team, then it's never going to work. So we've got that experience, and it begins from the job, from site. So it's being dismantled in the safest possible way. And then as soon as it comes down, we have a second level of check, which is done just to make sure this material is good enough for reuse before even talking about testing, because you wouldn't want to test materials that are bent or should go to scrap. Yeah.
Yeah, it's doing the right thing at the right time.
Yeah.
You look like you were going to say something, Tom.
I can give a bit of a perspective of this.
Do you want your diagram?
Yeah, you can put it up. Actually, so my experience, having worked for a year and a half on a demolition site and then a stockholder, and now acting on behalf of projects looking to procure reuse steel, I've got quite a unique perspective having been in each role. And I think one thing that you guys have picked up on is that there's considerations at the demolition that are going to affect what Roy has to do to the steel, which is then going to affect what you end up doing in the fabrication line. And if you don't make the right decision to demolition to recover good steel, then you're just going to cause a lot of issues down the line. So being able to communicate, what is required through the supply chain both ways really can help it kind of go through and take that full holistic approach, because what each individual silo is considering is equally valid but very different, depending on whether it's the design, fabrication, defabrication, recovery, demolition. So it's probably worth talking a little bit about how all of this fits into a process where you've got an existing structure, and one of the things that you'd look at is what are we getting out of it? Maybe doing a survey at the start to, is this building suitable for reuse? And what steel in there are we targeting for reuse? Making sure that the steel that you're getting out is suitable for Roy and Harry in their applications and the designers. Then going through that, you're going through the careful deconstruction, which is making sure that you're coming out undamaged. And as you mentioned, there might be a piece there where you would actually survey it as it comes out to make sure that it's not bent, dented, or twisted or whatever, and that, if it is, you'd send that to recycling. So kind of filtering that out at that point is really useful. But coming through there, it comes to the steel, reused steel stockholder, where there's as Roy mentioned, the testing and certification that happens, which all aligns to the standards and brings it up to where you can certify and warranty it as if it is new steel. So actually, you may get some uncertainty, opposition, but if you can tell them, this is just like new steel, there shouldn't really be any pushback on those. Throughout this whole thing, the design can be going on. There's a stock holding, defabrication, but by the time it gets to you, Harry, ideally, it looks like new steel. And if it doesn't, there's potentially issues, but if we can get it to you as close to new steel as possible, hopefully that's where it goes in. So hopefully that gives a bit of context of where everything fits in.
Okay. I think Harry and Titus, you both mentioned the SCI guidance, and I think Jonathan earlier mentioned about the SCI guidance, and then also the CEN 1090 document, and how the two documents work together. And so, is there clarity over which guidance to use, or how those two should be being used, and what the differences between them are? Do you want to give your lovely summary, Laura?
Me?
Yes.
Sure. So SCI P427 was published in 2019, Roy? Yeah. So, and this new document, CEN 1090/201, was published in 2024. So that's like a significant chunk of time where we didn't really have anything but the SCI document. And it really, really plugged a gap. It provides like invaluable information on how to design with reused steel, what the responsibilities of each party are. It's not a standard, so you can't just point to it and say we've met the standard, but it enabled the standard to be written. And so the standard now, well, it's a published document, which in standard languages it's been adopted for use in the UK, but it's not like a building code just yet, but it probably will be at some point. And that sets out, at least in my mind, it sets out the one missing piece that Jonathan alluded to earlier was the certainty over getting a CE or UKCA mark. So the SCI guide provides a process that you can follow. I think it needs a bit of interpretation. It hasn't stopped reused steel getting CE marked, but I think it's also not that it's not that certain over it. The CEN document provides that route to compliance that maybe was the missing piece, but it doesn't replace the SCI in terms of guidance. It doesn't replace it in terms of responsibility, in terms of like leading you through this whole process. So in my opinion, they're complementary. I think if you follow both, you get to a slightly different answer, which I think Tom can elaborate on a little bit more. But fundamentally, they are, the SCI guide is still relevant, still valid, still a really useful piece of guidance that like we wouldn't be here without it, I think.
Yeah, I can amend to that. You know, we've delivered projects with P47 as a guide, and we've done it with the 1090/201 document. And to be honest, they're both practical documents. The 1091, there's some slight differences in the testing, but both give you a reasonable answer when you design grades and everything. And really, it's a step. What we're looking at is we're a step towards it becoming part of standard guidance, you know, at Eurocode level for the designers. At this point, there's good industry acceptance, and if anyone is coming to you and saying, you know, we should be doing this, we can point to case studies, we can point to projects, we can point to these documents that gives you really good template to say, we can do this, you know, we've done it, let's get on with it.
If I can, just for context, so we sponsored the P427 document, and if I'm honest, the primary reason was because there was no guidance at all. I'm being totally cynical now. What we learned through the process is the standards tend to mimic processes or procedures that have been established. So it was clearly the case that it was necessary to get a process in place by the time the standards writers were considering it, and that's pretty much how that worked. 201 still isn't a standard, it's still only a technical guidance. But what 201 does is it actually wins the argument that EN 1090 allows reuse, because who would write a technical guidance note to do something you're not allowed to do? So we're in this strange scenario at the moment where technically it's not in the standard, but the standard's got an appendix which allows you, or basically says this is absolutely fine, and when we get round to it in the next God knows how many years to revise the standard, it'll be in it. But I would imagine that could comfortably be 4 or 5 years yet. P47 did actually advance from the original format, and in fact I would like to think 201 might in turn make that other step, but that's to be decided. And it's not just to forget, because most of these standards are adopted nationally with your own national forward or appendix. So the standards are adopted, but actually they're often, I mean, Highways Agency do this a lot. They write their own bit at the front and ignore great chunks of it. But it may be that it's worth, if you've got opinions, making sure they're heard. Because then when it does get made to be a standard or adopted in the UK, it's more fit for purpose.
Yeah, I think the idea of it being a stepping stone in these steps, P47 has gone through 2 versions, you've got 1090, we're seeing that momentum building. And I think a few years ago there was some people who would not potentially adopt P47, less kind of enthusiastic about the idea of reuse, who are now seeing the 201 1090 guidance, and that has brought them around. So we are seeing that kind of acceptance as we go through the kind of evolutions of the guidance documents.
Okay. So hopefully we've established there that it's pretty, the answer is all the guidance exists, you can do it, it's pretty well defined, we know exactly what testing we need. We talk a lot about the process for matching up the reuse sections with the steel that we have and at what stage in the project to do that. And I think you hear different things from different people. So from your experiences on projects, what do you think has worked well or not worked well? And you're laughing already, Roy. Oh dear. And do you have any advice about ways that people can approach that might make the process a little bit less painful?
I'll be slightly contentious for the audience, and Laura and I are a bit on the same page now, but the engineers can't drive the whole thing. So probably the first job we did, everybody bar the fabricator went straight down a hole, basically, quite literally a hole, because we'd all thought of all the technical arguments, all the issues that were going to happen. Nobody spoke to the fabricator, who then immediately discovered that he was going to snap all the probes off his drill, that the automated line was choking on it because it couldn't grip it. So this isn't a paper problem only, and in fact, based on what we've just said, a lot of it isn't a paper problem at all. So yes, the engineers are absolutely invaluable, and they're definitely the people that are driving this the hardest in the market, as far as I can see. But they're also often not at all in contact with the people that are on the coalface when the job actually goes live. So if you, and I would suggest a lot of your engineers are here already. So what I would say then is be mindful of the fact that after you've let go of it, somebody else has to pick it up and run with it. Now, you might not want to let go of it, another feature of engineers, in my opinion. But in the process, you're almost certainly going to have to. It's going to go to contractors, and then it's going to go to fabricators. So the specifications, the detail, etc. And the flexibility needs to be there to allow that to happen, as opposed to the thing fall over. It was quite embarrassing how many obvious things we missed about fabrication on that first job. I don't think Jonathan's here now, but I'm sure he would validate that statement.
Yeah, he's here. He's still at the back, yeah.
I mean, my background's commercial, so I'm going to find it hard to not talk about money.
I think talk about money, that's fine.
Let's talk about money. I think ultimately with all of these, beyond it being the right thing to do, there's got to be a why. Mm-hmm. And if you're not clear on what the why is from the start, that's when it's those jobs where from the very start there's been a clear why, what are we doing it for. It's when we're seeing quite a lot of jobs now where it's almost like, you know, you see lots of projects where we call it like sustainability bling, where there's just things thrown in there because it'll add a few sort of bits of greenery to a job, you know. And it's when a job's designed, everything goes in the normal way, normal procurement, and then in a mid-bid you'll get, oh, and by the way, reuse steel, what about that? What about it? What do you want us to do? And that's when you'll see from a, you know, we might be tendering on a stage 3 design, that model snapshot there that will flag up, you know, you can go through and say, right, well, 200 tons of that can come from reuse, and that's going to be fantastic. Then the design changes, you know, the design changes away from things that are readily available in stock, so that goes away. You run into issues from an end client perspective on cash, ultimately. You know, it might be in a stockist, someone's got to physically go, and it's a transient stock, right? Someone's got to physically go, and if it's Roy, tell Roy, I want that stuff there, and, you know, agree payment terms, agree ownership, vest in whatever, you know, the practicalities of who owns that material, how is it reserved for the job, and then if the design changes, you know, we're seeing so many jobs where it's reuse is talked about as an add-on, and they're the ones where what you actually physically achieve by the time it's all said and done is very little. You know, it starts as a good idea, but not a lot happens. It's the jobs where it's a fundamental part of the project from the outset that it'll achieve what it set out to.
I would just add to that, because sorry, Laura, it's fundamental in the sense because the early engagement is critical, but the passage of time is fatal. So again, it's to be mindful of. So people know, they've heard me moan before, but if we're at stage 1, we can't hold material till stage 5. So there has to be that allowance within that. Engineers don't buy metal, unfortunately.
And I think just picking up on that, sorry, is we talk a lot about early engagement, and the industry's got a lot better for early engagement. But early engagement without trust and commitment kind of means nothing. We're always there to give advice. We'll come in for jobs when they're, you know, a fag packet sketch and give advice, and that's great. But it's on what basis are you engaging at an early stage? If there's no contractual relationship, no commercial, financial relationship, ultimately it will, like Roy said, the passage of time is going to kill it.
I think there's a piece here of what does early engagement mean and what decisions are you making at what point, and come back to the engineers. There's no other material that an engineer is going out and buying at stage 2, or saying the client should go buy this steel. You wouldn't do that for anything else. Why does that seem to be the case with reused steel? And obviously there's issues with supply and demand and trying to get things through planning. But actually, you know, there's early engagement in a sense of you should be considering it, you should be thinking about how that plays into your overall, you know, procurement, your carbon targets. What do I need to do in my design that might allow for reused steel when it gets to the fabricator? What do you need to know for your tender? But does that mean buying 200 tons from Roy at stage 2 and then having him keep it in his yard for 3 years? Probably not, you know. So there is that question of act early, but do the right actions at the right time.
I think that's a perfect example of what we've learned going through the process. So the very first time that steel was reused at HTS was, it was being kind of designed in 2020, 2021. The job received practical completion in 2022, so it was the first use of reused steel in a commercial practice. At that point, no one has really any idea what they're doing, you know, us included, and you're trying to solve problems as they arise. So, you know, one of the first problems is, okay, great, let's do it, but how do we do it? So then you have to kind of think ahead. It's like, okay, where does the steel come from? How can we make sure that it's incorporated? So, and this is something that we've learned as a practice, is by overstepping and by causing problems down the line, but in the spirit of trying something new, you have to make those kind of little mistakes and then correct as you go. So by getting into, and then, you know, everyone says, oh, early engagement is really necessary, so you're like going to early engage. But that actually causes problems in this context. So only by doing that do you learn those lessons. And then, and it's not just lessons that are learned internally, it's lessons that are learned with all the collaborators. And then you do it slightly differently the next time. So upstairs we have a case study board where we've looked at all of our reused steel jobs and kind of picked out what has been enablers like overall and how they've learned from each other. And I think this is a really interesting thing that we have to acknowledge is all part of the process of messing it up slightly and then learning and doing it differently. And being open and upfront about it, I think, is also really important. So I think we wouldn't do it the same way as the first time we did it. But that just shows like actually massive progress amongst the whole industry, that we've got to the point where they're writing now a published document to go and send 1090 to facilitate this. So yeah, I would agree that early reservation of stock is not the way to go. But the fact that we know that is actually quite, it's a good outcome.
Yeah.
Did you have something?
Yeah, just to add, I would say we should think reuse first. From the onset, and I think also the pre-demo audit needs to be more reuse focused.
Yeah.
To be honest, I've seen audits where it doesn't really make sense at all. Yeah, and then we struggle. So if it's more reused focused, I think it gives it sets the tone for the conversation for reuse.
Yeah, I would definitely agree with that. With the like, on a project where you're going to demolish something that you're going to try and reuse, that work that you do before you start demolishing everything is so important, to look at what's there and what you think you want to use.
And just to add to what Harry said, I think the why do you want to reuse should be intentional as well.
Yeah.
If there is no intentionality to it, then forget it.
I think picking up on what you're saying there as well, you need proper practical input. Because I can remember in presentations I was doing a few years ago, I started to argue quite strongly against deconstruction, because it's too easy to say, we want reuse, take that all down carefully. Because if you do the work correctly at the front, you know that 3/4 of it's going in a skip or whatever anyway. So there's got to be that degree of practical interpretation, and then everything goes more simply after that. I think there was probably over-ambition at the start.
The friction with this, I mean, it's sort of, I don't know if Owen's still in the room or if he's upstairs, but going back to sort of the 7 steel sort of approach, is which with a lot of the reuse, we're trying to productize a commodity market. You know, fabricated structural steelwork is a commodity. It's not a product. If you say looking at rebar as a component in a product. It's different. You know, you do have a different manufacturing cycle. You do have a different stock holding pattern. You know, we don't everything. We talk about just in time. It's not just in time. You know, but it's a bespoke commodity product. It's very difficult to. You're changing the whole buying approach, especially if you don't want that reservation of stock. It just every little step of it you take, it spins off in different directions. It's far more nuanced just because of the way that structural steelwork is consumed in this country.
Right, I'm going to have a quick look and see if we've got any questions. Oh, someone's asking you to plug Emerald.
Yes, so
I saw him send that.
It's very clever how you did that while you were talking.
yeah, so very high level. Emerald Steel was incorporated or birthed from Coleman's Group. A lot of us should know Coleman's. Like I said earlier, we've got over 65 years of demo experience. So, well, if you do want to hear more about Emerald Steel, I think at the end of the event, during the networking and drinks section upstairs, I would spend more time, maybe 5 minutes of your time to tell you more. But yeah, so we've come out of the Coleman's Group as a standalone business just to push the reuse and support the reuse business.
Great, thank you. Okay, fabricators consider processing reclaimed steel riskier and more expensive due to worst-case pricing assumptions in defabrication. True or false?
Both.
Both.
Yeah, I mean, again, not to to go back over it, it depends on the procurement route. It depends on the information that's available to you. It depends on what, you know, if you're in a traditional sort of lump sum D&B and you've not got great information about what you might potentially be reused, but you are responsible contractually for delivering a certain scope, and that's it, your fixed price lump sum, yeah, you've got to make an assumption. Like you know, fundamentally all we do when we're bidding for work is measure risk, that's all it is. And if you can't quantify that risk and you've been forced to accept a certain amount of it, like to Jonathan's point earlier, ultimately in this whole chain, the fabricator bears that risk. It all comes down to us. So I think that can be true or false depending on the project you're looking at, the information that's available to you and the contracting mechanism, to be honest.
Do you think it's moving towards a point where you have a better understanding of that process and specifically what the risks might be so that you are able to quantify that a little bit better?
We certainly have a better idea of which parts of the process that we like to do ourselves and which we like others to do for us. Yeah.
Yeah. Just to add, I think reducing the risk that sits with the fabricators comes from the quality of product that goes out to them. So I said earlier, skills, the techniques or the skills required for dismantling or deconstruction is very important. So you wouldn't want to just get down, I would normally call it a banana, a bent stuff to Harry. That would make no sense. So before you even load the materials from the site or from the job, when Harry sees it coming in, it's a straight piece of steel. So that reduces the work he has to do on the steel.
It's like each person in the process taking responsibility.
There's responsibility for everyone. And I think the gap within the industry, especially with the demo guys, sorry to say, so many demo contractors shy away from it, probably because they do not have the skills required. But we've still got people out there who have these skills. They've tested it, they've done it, and it's working. It has proven to be a good solution to the problem of reuse at that level.
I think one thing that's worth mentioning is that at the moment we're talking about the stockholder model. Where that comes into its own with bells on is if a company's taking a building down and has ambition to reuse the material back into that same building, because then they can be setting a cost hurdle that's off the charts or not. So we don't get involved with that specifically, but that's the big fear. If somebody said, well, I'm taking this building down and I want everything out of that over there, then suddenly it's like, holy cow, could be very, very expensive. So we're managing our cost to supply the fabricators with material they know they can use to reduce all of that. But as soon as you go to this internal circular economy, which I'm not against at all, but then this becomes seriously fundamental as to who's paying for what.
That's one of the things we learned the very first time we did this, was that we were looking to reuse stock from the site, and actually program-wise made no sense, and it was infeasible. So that was an interesting early lesson learned.
But I think that the question was there, and I think it's gone, but the argument or the issue with that is that if I think Megan said it earlier, if a client has got a building that they're demolishing and they can't reuse that steel themselves, there's currently no real incentive for them to demolish it in a way so that that steel goes out to the market and helps to drive that reuse market. So surely you're getting into a position where, yeah, it absolutely makes more sense for you to not be using the steel directly from that project, and in timescales and cost and everything else, it probably makes more sense to buy it. But if there's no driver for clients to demolish their buildings in that way, then how do you get to that point where there is a market and that model works?
I think that's even talking about the sort of few percent projects where that's even being discussed. What we need to address is all the demolition and how to reclaim all the viable steel from all the demolition, even if the new structure being built is not going to be using reclaimed steel. I think that's really important, and Megan said it earlier. It's a really big problem. But I do think that for the small slice where you've got a donor and a receiving building within the client's portfolio, there must be some sort of financial mechanism where you can sell it to you and then get what you need to efficiently reuse the material at the right time and the right sections, rather than just sort of forcing in a donor building into a new structure, because it's just not feasible. It's a waste.
Okay. Shouldn't we just be recycling the reclaimed steel in our new EAFs powered by decarbonised electricity rather than going through the tricky reuse process? It is a good question.
Yeah, by all means. It doesn't have to be that tricky, so that's the first thing. Make it not tricky. That's my main ambition. I don't try and do the tricky stuff. I've got a business to run. I've got to make money to keep the staff employed. So if it's unduly tricky, we don't do it. So that's point one. Then after that, we're talking about circular economy in general principle. Using something twice is always better than the re-input. Now, fully accept, depending on different people's attitudes, that's a different position you take. But we hear a million different positions on renewable energy and every damn thing else. But if we accept that circular economy is valid, then reuse is the first port of call. And I accept it to be valid. I just avoid the tricky stuff.
I think that's a very good point earlier, saying, even if you're recycling, you've still got to heat it up to 2,000 degrees. And even if that's renewable energy that could have been used to decarbonise our other part of the grid or our home electricity. So if there is a certain proportion of the steel which is well suited to reuse, can go through the supply chain at a reasonable cost with a standardised approach, even if that's 5%, 10%, that's 5%, 10%, which is a massive carbon saving, even compared to recycling. So it's not that reuse is going to take over everything, but it's that, where does the balance lie, and how do we get to that natural balance that should be there? Because I've seen some really nice steel, which is perfect for reuse, not being reused and to go straight into recycling.
Yeah, it is about 1/10 of the embodied carbon, so it's not an insignificant saving. And as Roy said, don't do the tricky stuff. Let's start with the easy stuff.
Okay. What market signal is needed for uses other than structural applications to be catered for, e.g. lift counterweights?
I'll pick that up because I think I know the context.
Okay, great, because I was slightly confused by that
The
one.
very basic point is that steel is used in a vast array of things. People have a nasty habit of thinking it's come out of an office, I need to put it in an office, or it's come out of a shed, I need to put it in a shed. Steel's used in an awful lot of places, and an awful lot of that application is suitable for reused steel. I mean, I used to use the example of bollards, essentially. That is people, and we've just seen it, piling, steel piling. People will specify brand new steel for piling, even though the structure is going to be reused, because it's a different set of engineers that look at the piling detail. So it's just a question of where else can it be used. The problem is I don't know what market signal is required. It's been hard enough to make enough noise and impact in construction without then worrying how you trigger it. But I think it comes down to mandate. Where is carbon saving mandated anywhere?
But I think you're, sorry Tom, you're looking for the steel reuse opportunities in domestic settings is a good example of this, right? Because a steel that you've taken out that's come from a commercial building might not be able to go into a commercial building because you've had to cut it a bit shorter and do something slightly different to it, but it might be perfect for a domestic project. And so maybe actually moving it from one type of building to another is a much better way of dealing with it than trying to put it back in somewhere the same.
And the other thing to remember, and I forget it a lot, but steel reuse is a disruptor.
Yeah.
So the people who buy lift weights don't want your reused metal because they've got a whole supply chain that buys lift weights. It doesn't mean it can't happen. It's how you are a disruptor. It unsettles the marketplace. It unsettles the situation. And definitely mandating legislation changes that.
Yeah. Sorry, Tom, did you want to?
Well, I was actually just going to say what you said.
Sorry.
There's a lot of, we've had a lot of case studies which have been driven by, central London, high embodied carbon targets with high-end offices, which have been great case study for lessons, but actually a lot of reuse is suited to large-scale industrial buildings, warehouses, and the idea of domestic use, actually feeding things like temporary works into domestic use. A lot of these columns that you use for temporary works are perfect for house extensions. So it's like if you look at take a step back and look at the holistic picture, there's a lot of opportunities that kind of, occur when you get outside of your London bubble. And then also the UK bubble, there's other application. We're almost leading the way on this in the UK on guidance. But we're seeing Australia and the US and other countries actually start looking at adopting guidance and seeing how they can share the lessons. So that is there's a lot of expansion of steel reuse that can happen with what we already know and what we can already deliver.
I'm going to skip a couple of the questions there because I think we've kind of talked about similar things, but maybe let's go for demo contractors' waste stream. How does the value of steel for reuse compare to demolish for recycling? So how does reuse compare to scrap value, I guess? And how easy does reuse need to be for it to be viable? Maybe that's one that you might be able to answer, Titus.
Well, I'll try. So, so we've compared the cost between a traditional demo and an engineered deconstruction process, and we found out there's not much difference. So, I mean, that should stem from our experience of how this is done or how this could be done. So for us, it checks out, and I think so. The value for the material itself, reuse as against the scrap. I don't know what Roy would think, but I think I would say because, well, I don't deal with the commercial side of things, but it all lands with negotiation. So, say for instance, if we were to sell to Roy, I mean, it depends what offer is there on the table. But to be honest, on the grand scheme of things, for us and from the experience we've had, looking at both systems or ways of taking these steels down, it checks out or balances out for us. It's not expensive.
It comes back again to not doing what needn't be done. That's definitely the first thing.
Yeah.
The other thing which is important, and we're seeing it, and we're going to see much more in terms of movement this year, but you're making the judgment at a point in time that steel prices aren't very static at all. So I was alluding earlier to 10 years ago when I was doing the presentations, I was explaining what a small margin there was between scrap and the price of new steel. 3 years ago, it was massive. A year ago, it closed right down to next to nothing again. So it's a dynamic consideration. It's how much work can we do to recover this for what then is going to be viable. And in the same way we try and give the fabricators material that's as easy for them to use as possible, we try and buy from the demo guys the stuff that's the easiest to get, because I don't want to pay a whacking great premium to then not be able to recover it if the prices move. Because we can be holding material for 2 or 3 years. The material can literally go up or come down £300 or £400 a tonne. 30–40%.
Yeah, I think there's a point here. I mean, when it comes to commercialisation, at a very practical level on demolition site, you know, if you're getting a uplift of £100 a tonne or whatever it is, if it costs you 50 quid a tonne to get out, that's perfect. If it costs you 200, then, you know, it doesn't work out. And there's some low-hanging fruit steel in the building that probably is a lot easier and less costly to get out. And there's some that is going to cost more. So, you know, that has to be assessed at that level, and you do it through experience. But talking about the wider kind of commercial considerations, if by the time it's gone through the whole supply chain, if you're getting product that is either cost the same, if you can get it through at the same cost of new steel, however that varies, or a little bit less, what you've done is you've saved 97% of the carbon for free. So when we think about these things where it's like, oh, it could be 10% more, it could be 5% more, you're looking at a 10% cost uplift maybe for 97% reduced carbon. And I think you'd struggle to find any other sustainable product that has that same kind of carbon benefit for the cost.
Fortunately, I think that the next panel is talking much more about the economics of this, so we've led into them quite nicely. Maybe let's do what specifics in a pre-demo audit are the most useful to enable reuse. I'm sure that probably Tom and Laura and Titus have all got thoughts on this.
So there's some work that we've been doing with Reusefully and some of our local councils about what would a circular economy pre-demolition audit look like. And this is a published document that we can send around, but it's really looking at what information do you need from a pre-demolition audit. There's that product-specific information, and when it comes to steel, you know, it's identifying what the high-level information is you need to know to take your next steps for steel reuse. You know, things about, is it concrete encased, is it galvanized, things that you can quite easily find from a pre-demolition audit. You know, we found pre-dems not that useful, but there's also the case that there is also more specialist. It doesn't all have to be captured within a pre-demolition audit. You can capture the high-level stuff, but once you've got that indication that, yes, the project is on board, the client's on board, we want to actually have a good assessment on this, we would look at doing a more detailed survey. And that's kind of looking at creating an inventory, looking at more on a member-by-member basis, maybe getting the BIM model or the existing drawings and going through and saying, right, this, what Roy and everyone has been talking about today about what the good steel is, that's going to be good to go to Roy and through the process. There is a process that you can use to actually go out and look at a building and say, yeah, these are the beams that we want to get, these are the columns we want to get. We've been doing it in practice quite a bit as a standardized approach, but it's just what we've been doing. So, yeah.
I think this is a good example of where engineers don't really need to kind of step into the realm. So we can really help with getting early stage information, like from archive drawings and understanding what the age of the steelwork. Is it likely to be tapered flanges? You know, what's the likely grade going to be? Is it encased, etc. Early desk study stuff to say whether it should be viable to take the next step, to have a look. But from the point at which you're doing a pre-demo audit, I think the structural engineer is less able to advise because it's a commercial decision and it's a demolition deconstruction decision. So I think that's at the point where I would say, you know, over to you guys.
Okay. Whilst I'd love to ask the question, which borough is more hungry, I think we've run out of time. So we'll have to leave that one for another time. But thank you very much to all of our panelists and to all of you for all of your great questions.